A off adder is implemented with exclusive OR gate and AND gate. A full adder is implemented with the two off adders and one OR gate. A full adder is implemented with two off adders and one OR gate. The propagation delay of XOR gate is twice that of AND OR propagation delay. The propagation delay of AND OR gate is 1.2 microseconds. A 4-bit ripple carry binary adder is implemented by using 4 full adders. The total propagation time of this 4-bit adder is in microseconds. It is a question. It is the question which is on the combinational circuits on the broader perspective that you are looking. And in specific, it is related with the arithmetic circuit. It's a very good question. It's a very good question. To answer this question, we need to know the knowledge to implement the off adder. XOR gate and AND gate ka connections kya hai? And similarly, to implement a full adder, to implement a full adder, two off adders and OR gates को कैसा connection देना, this knowledge आपको मालूम होना चाहिए. The knowledge of this, we are finally coming to this 4-bit triple carry binary adder, right? And we are looking those details. Off adder देखे तो off adder का अगर inputs x and y, if you are giving the name of the inputs of off adder as this x and y, then you are having a knowledge, some equation is this and a carry equation is this. If you are looking to the circuit, when it is implemented with the XOR and AND gate, it is a circuit will be having x and y are the inputs. This is coming to be some output. This is coming to the carry output. Now, by using this off adder, by using this block, off adder means this block बोल सकते अपन. By using this block, if you want to implement a full adder, then full adder ka inputs you need to know x, y, and z, where z is the carry input. And full adder some equation, carry equation आपको knowledge में होना चाहिए. Some equation XOR between x, y, and z. Carry equation is exclusive OR between x, y, and with carry in. Z is the carry in or with x, y. It is the carry equation. So इसके हिसाब से, if you are looking here, so x, y are the inputs to this off adder. And if you are coming to this, it is another off adder. इसका inputs देखे तो we are looking here some output exclusive OR between x, y, and z. So इधर से मिला आपको x, y exclusive OR between x and y. It is some output from this first off adder. That is one of the input here. Second input to this exclusive OR is the carry input z. So overall circuit some output is here. So some equation you are looking as exclusive OR between x, y, and z, right? And coming to the carry equation if you are looking here, exclusive OR between x, y, and z. So this is a exclusive OR between x and y. That is one of the input to this AND gate, right? And other input is the z. That is the carry input. So this is your carry input, right? So basically this product exclusive OR between x, y, and z is from this AND gate, that is off adder to AND gate output. It is the off adder to AND gate output. And off adder 1 AND gate output is x and y. Now it is the equation we want for carry. So we need here a OR gate. इधर एक OR gate का जरूरत है. So OR gate का output equation है exclusive OR between x, y, and with z or with x, y. So now we are talking based on this. इसके हिसाब से अपन बोल सकते this will be your off adder 1 बोलना पड़ेगा. This will be your off adder 2 बोलना पड़ेगा. So whenever we are having an off adder, sum is always available from the exclusive OR, and the carry from the off adder is available from the AND gate. Now all these together, all these things together is now it is full adder. ये पूरा मिलके you are having basically as a full adder, right? तो each full adder में आपको दो ऑफ एडर ब्लॉक्स मिलेगा, एक ऑर गेट मिलेगा. वन इंपॉर्टेंट थिंग इधर आप क्रिटिकली सोचना पड़ेगा, क्रिटिकली आइडेंटिफाई करना पड़ेगा. जो कैरी इनपुट है, दैट कैरी इनपुट इज कमिंग टू ओनली ऑफ एडर 2. जो कैरी इनपुट मिल रहा, वो कैरी इनपुट ऑफ एडर 2 को मिल रहा, राइट? ओके. नाउ by using such full adders, we are having implementation of a 4-bit ripple carry binary adder. 4-bit ripple carry binary adder. So 4 full adders are required. 4 full adders are required. So based on this description, this is one full adder. This is another full adder. This is another full adder. This is another full adder. So we are having in need of 4-bit ripple carry binary adder. So that 4 such full adders are required. 4 such full adders are required. So inside if at all you are looking, each full adder, it is one ऑफ एडर. ऑफ एडर 1 नाम दिया, इधर ऑफ एडर 2. So this is ऑफ एडर 1. It is ऑफ एडर 2. This is ऑफ एडर 1. It is ऑफ एडर 2. This is ऑफ एडर 1. It is ऑफ एडर 2. Right. Consider having 4-bit numbers. अपने पास 4-bit number A3, A2, A1, A0 and 4-bit binary number B. 4-bit binary number B is B3, B2, B1, B0. Right. And we are having the carry input is C1, suppose it is the carry input. Now from this we are looking, the sum output will be here, it will be C0, S0, some output S1, some output S2, some output S3. And if you are looking at the carry outputs, carry output we are having here, it is a C. Sorry, do one thing, you name this as C0. तो इसके हिसाब से इसको C1 बोलेंगे. तो C0 इनिशियल कैरी, इनपुट कैरी. ये C2 है, this is C2, this is C3, this is C4, right? So whenever we are giving these inputs to this triple carry binary adder, for this 4-bit triple carry binary adder with the initial carry of 0, initial carry of SC0, whenever these numbers are fed to 4-bit triple carry binary adder with the initial carry of C0, the sum bits must be S3, S2, S1, S0, carry bits must be C4, C3, C2, C1 respectively from MSB adder to LSB adder. ये मिलना चाहिए. तो क्वेश्चन में क्या पूछा? द क्वेश्चन में पूछा, वी आर हैविंग द प्रोपगेशन डिले ऑफ AND गेट और OR गेट. ये AND का नहीं तो OR गेट का प्रोपगेशन डिले बताया 1.2 माइक्रोसेकंड्स, राइट? एंड एक्सक्लूसिव OR का प्रोपगेशन डिले बताया 2.4 माइक्रोसेकंड्स. Because twice बोला, twice means 1.2 into 2, 2.5 microseconds. और ऐसा भी देख सकते, अगर इसको अपन TPD नाम दिए तो इसको नाम देना पड़ेगा 2TPD. क्वेश्चन क्या है, whenever a 4-bit triple carry binary adder is built with this given information, what is the propagation delay associated with this 4-bit triple carry binary adder? ये है अपने पास क्वेश्चन. So if you are looking here from the given data, इसका डिले है, एक्सक्लूसिव और का डिले है 2 TPD, इसका डिले है 1 TPD, इसका डिले है 2 TPD, इसका डिले है 1 TPD, इसका डिले है 1 TPD, right? 1 TPD. Now, from a full adder, we are looking to sum. It is available with what delay? If you are checking, sum is available with what delay? If you check 2 TPD is one of the input, right? Other input may be coming directly, but the output मिलना बोले तो it is to need of the output from this exclusive or first exclusive OR gate और ऑफ एडर 1 का exclusive OR gate से मिलना चाहिए, बाद में ये करेगा. So that effectively 2 TPD plus 2 TPD, it is coming to be 4 TPD. And coming to this carry output. So carry output, we are looking one input to this OR gate directly from the off adder 1 AND gate. So 1 TPD से मिल रहा. दूसरा मिल रहा ऑफ एडर 2 का AND गेट के बाद में, ऑफ एडर 2 का AND गेट के बाद में, ऑफ एडर 2 का AND गेट एक इनपुट मिल रहा अपने को डिले से 2 TPD से मिल रहा. दिस इज अवेलेबल हियर विद अ डिले ऑफ 2 TPD. It is available with a delay of 2 TPD, right? And of course, this may be available directly. This may be available directly. 2 TPD में होने के बाद it is passing through this and also this OR. So effectively 2 TPD plus 1 TPD plus 1 TPD. We are looking, it is available after 4 TPD. So if at all I am having an independent full adder, उसका sum output मिलेगा 4 TPD के बाद में, कैरी आउटपुट मिलेगा 4 TPD के बाद में. एंड वन पॉइंट अगेन आई एम रिपीटिंग, जो कैरी इनपुट है दैट इज एंटरिंग इनटू द ऑफ एडर 2 एक्सक्लूसिव OR. इट इज एंटरिंग इनटू द ऑफ एडर 2 एक्सक्लूसिव OR. बोथ इंपॉर्टेंट क्रिटिकल पॉइंट टू आंसर दिस क्वेश्चन, करेक्ट टू गिव द करेक्ट आंसर टू दिस क्वेश्चन. बोथ क्रिटिकल पॉइंट है, इट इज अ वेरी क्रिटिकल पॉइंट. नाउ इसके हिसाब से वी आर लुकिंग नाउ. So inputs we are having here A3, A2, A1, A0, right? Here this is B3, it is B2, this is B1, this is B0, and input carry C0, right? So whenever we are having, these are the inputs. Whenever we are having, these are the inputs. Critically देखो, for off adder 1 of each block, off adder 1 of each block, each yellow block is a full adder. Okay, जो color these are used for, the same thing I use here. Each yellow color block is a full adder. So within that full adder, we are having 2 off adders, 1 OR gate, 2 off adders and 1 OR gate. So off adder 1 के लिए inputs for all the full adders एक ही साथ में मिल रहा. For all the 4 full adders, first blocks of off adder 1 are getting the inputs simultaneously. Whenever the inputs are available simultaneously, from all these blocks, we are looking, the outputs एक ही साथ में मिलेगा. From all these block outputs available at a time. So what is the delay associated? So sum का देखे तो 2 TPD and carry का देखे तो 1 TPD, off adder का देखे तो. So effectively highest one is the dominating, so that to speak it is available with a delay of 2 TPD. Delay of 2 TPD, right? Same thing here also we mentioned, it is available with a delay of 2 TPD. बाद में we are looking, this must be sum output S0. This is a sum output S1. This is a sum output S2. This is a sum output S3. Right? Now, the sum output is available. Sum output is available here 2 TPD and इसके लिए 2 TPD. So we are having some output is available from this full adder 1. इसका नाम देना पड़ेगा full adder 1 के हिसाब से. This is to be full adder 2. It is to be full adder 3. It is to be full adder 4. Right. So full adder 1 से some output मिल रहा with a delay of 4 TPD. With a delay of 4 TPD. Right. So here we are looking for this carry output. For this carry output, this is to be named as, it is to be named as now C1. It is to be named as now C1. So C1 कितना टाइम के बाद में मिल रहा? C1 is available, of course, after 4 TPD. After 4 TPD. So here, this sum output, and here this is the carry output C2. They are available here. They are available here after knowing the carry input. After knowing the carry input to this off adder 2. After knowing this carry input to this off adder 2, we are having effectively output from here. तो कैरी इनपुट किधर से मिलेगा आपको? कैरी इनपुट मिलेगा फ्रॉम दिस फुल एडर 1 आउटपुट. तो फुल एडर 1 आउटपुट से कैरी इनपुट मिलेगा. फुल एडर 1 आउटपुट से वी आर हैविंग दिस C1. C1 is coming to be here the carry input for this full adder 2. So this carry output what we are having, this carry input what we are having, it is entering to where? It is entering to off adder 2. It is entering to off adder 2. It is entering into off adder 2. By the time all the off adders are completed this work, ये पूरा off adder 1 blocks एक ही साथ में काम कर रहा. So already this is available here, but it is waiting for this C1. For this C1 it is waiting. So C1 is available after 4 TPD. C1 is available after 4 TPD. Right? After 4 TPD. बाद में we are looking the delay associated with the off adder 2. If you look, the delay associated with the off adder 2 exclusive OR है. Exclusive OR का delay 2 TPD है. 2 TPD है. Right? And carry देखो 1 TPD plus 1 TPD. इधर भी 2 TPD है. Okay? So XR 2 TPD and here this is OR 2 TPD. So that ये मिलने के बाद सम मिलने के लिए, कैरी मिलने के लिए 2 TPD टाइम होना पड़ेगा. So 4 TPD plus 2 TPD, it is coming to be 6 TPD. It is also coming to be 6 TPD. Now this C2 is available for this full adder 3 as an input. It is available with a delay of 6 TPD. This C2 is basically entering. This C2 is basically entering to off adder 2. So ये off adder 1 के लिए वेट नहीं कर रहा. It is completed its job. So it is coming as an input. This C2 is coming as an input to the off adder 2 of full adder 3 with a delay of 6 TPD. बाद में सम एंड कैरी के लिए 2 TPD 2 PD होना पड़ेगा. So that it is 8 TPD. 2 PD plus 2 TPD. So 8 TPD. Right? Now the same knowledge you are extending here. It is a repetition now. This C3, this C3 is the input to the full adder 4 of adder 2. So it is available here. It is available here with a delay of 8 TPD. With a delay of 8 TPD. Right? Later we are looking for sum and carry purpose. For sum and carry purpose, we need 2 TPD. We need 2 TPD. Here 2 TPD. Here there is carry. It will be 2 PD. 2 TPD. So that sum is available with a delay of 2 TPD after knowing this. So 8 TPD plus 2 TPD, 10 TPD. And we are looking to this carry C4 is also 10 TPD. 10 TPD. So based on this, we are looking to the answer. Based on this, we are looking to the answer. So answer is 10 TPD. TPD we took as 1.2 microseconds from the given data. So answer is 12 microseconds. The answer to this question is 12 microseconds. So this is the answer to this question. It is the answer to this question. Answer to this question, again I am writing here, answer to this question is 12 microseconds. Right? So very critically you have to think, These off adders what we are having in each full adder, the first off adder say all they are completing their job simultaneously. Why? Because external inputs A3, B3, A2, B2 and so on, A0, B0 जो मिल रहा directly off adders को मिल रहा, first off adder को मिल रहा. So first off adders of each block they are completing their job within the 2 TPD time. So there is a 2 TPD time. Course from this we already took explanation. बाद में if you are looking off adder twos are looking for the carry input. Full adder 1 के लिए तो carry directly मिल रहा, hence effectively sum is available, carry is available with 4 TPD delay because मिलने के बाद off adder 2 XR है, already है अपने पास, देखो XR 2 TPD इधर and R, so effectively 2 TPD add हो गया, so 4 TPD for sum as well as carry. If you are looking to the full adder 2, इसका इनपुट होना C1 मिल रहा है इधर 4 TPD डिले से. So C1 is entering only to the off adder 2, not affecting to the off adder 1 of this full adder 2. So it is available with the delay 4 TPD, बाद में 2 TPD add हो रहा. So that 4 plus 2, 6 TPD. And similarly coming to this, it is looking for the C2 मिल रहा full adder 3 के लिए with a delay of 6 TPD. This C2 is entering into the off adder 2. It is not giving any effect on the off adder 1. So after knowing this C2, we are having the delay for sum and carry from this off adder blocks and OR gate is 2 TPD. So that 6 plus 2 8. 6 plus 2 8. And here full adder 4 8 TPD से मिल रहा, C3 बाद में 2 TPD add हो रहा, so 10 TPD. So TPD 1.2 microseconds लिया, hence our answer is coming to be 12 microseconds. So this is the correct answer. This is the correct answer. So it is very critical question, important question. Is the correct answer is only this is the right answer. If you are looking from any other source, something else as the answer is wrong. Why I am mentioning something else means I was looking from YouTube, which YouTube say from other platforms, they are looking something like this: full adder 4, full adder 3, full adder 2, full adder 1. Right? इधर देखा inputs ऐसा है. Okay, all this probably known to you. So A0, B0, A1, B1, A2, B2, A3, B3, right? And this is, sorry, C0, it is S0. This is S1, it is S2, this is S3. And we are looking here, it is C1, it is C2, it is C3, it is C4. People are giving answer wrongly as something like this. Delay they are giving as n-1, this formula they are using, n-1 delay associated with the carry plus max among sum and carry, max among sum and carry, ऐसा formula लेके बता रहा था. So n is here 4, so n is 4, so based on this people are mentioning answer as 3 into carry delay. Carry delay कितना मिल रहा? 4. So 4 TPD. And among these two maximum, of course, happen to be both are same, 4 TPD. So they are giving this as 16 TPD, and TPD is 1.2 microseconds, and 16 TPD का answer from the YouTube you are looking as 19.2 microseconds. ये answer आपको मिल रहा. You are having, this is the answer. It's a big mistake. It's a wrong answer. So simply using formulas you are giving, एक क्वेश्चन के ऊपर तो आंसर गलत मिलेगा. It is not going to the right answer. Be careful. From many sources, it is observation from the YouTube and even from booklets में भी कुछ other platforms से गलत आंसर मिल रहा. गलत आंसर they are giving. It is wrong. The correct answer to this question is this 12 microseconds. It is the correct answer. The reason behind this is just simply the by hearting formula they are talking. It is not correct. Whatever the carry which is entering only to the off adder 2. If you are thinking like this with a proper attention, then you are having the right answer. The right answer is this 12 microseconds. If you look to this question, a question 2015 gate में पूछा था. So the question is related with the number system. Consider the equation for 3, the base is x, is equal to y3 base is 8, where x and y are unknown. So we are looking here, this x, that is the base of this number, is unknown, and y is the digit in this octal number system. Whenever the base is 8, ये तो octal number system बोलना पड़ेगा. So a octal number system में a y also unknown. Question is the number of possible solutions. The number of possible solutions. A है question. It was a question as a numerical. So from this given data, we are having few conclusions. A given data से कुछ conclusions बता सकते हैं. So from this 4-3 base of x से बोल सकते हैं, whatever the x value will be having, that is the base of this number system must be greater than 4, must be greater than 4, right? And coming to this, we are having from here the conclusion is whatever the unknown value we are having y must be less than 8. Y must be less than 8. So it is a standard thing. अगर आपके पास number system है, we are having a number system which is the base of say 4. अगर आपका number system is the base of 4, the discretes क्या मिलेगा आपको? 0, 1, 2 and 3. और in general, whenever अपना number system is the base of R, the discretes will be 0, 1, 2 and so on, R minus 1. It's a standard thing, all of you know well. ये तो सबको मालूम है, right? So having this knowledge, we are having this conclusion here. So here, whatever the y we are looking, these are the discretes. So that must be less than this base. So this is the base we are talking here, right? So this is the base we are talking here. The radix or base, so that this y must be less than 8. And same knowledge से बोल सकते हैं जो x मिलेगा a number system के लिए, this x must be greater than 4. Having this knowledge, you have to proceed further. So we are expanding this, it is having base is x, so that it is a 4x plus 3. Coming to this, base is 8, so that 8y plus 3. So this 3 you can cancel, and from this we are looking here, this is 2y is equal to x. 2y is equal to x. So how many possible values will be having is the question for us. So this is one thing, and other thing we are having these conclusions. A conclusions, while looking to these conclusions, a conclusions देख के अपन आंसर बोलना पड़ेगा. So x and y we are talking. So y must be less than 8 बोला. तो must be integer. अगर y आपके पास 7 है, then x will be, based on this, x will be 14, right? So this is definitely one possibility on x and y. Similarly, अगर y value 6 है, y value 6 रहे तो x value based on this is 12, and it is one possibility. Similarly, अगर आपका y value is 5 है, अगर y value 5 रहे तो x value 10, it is also one possibility. So these conditions are satisfied here. So y is less than 8 and x is greater than 4. A condition satisfied for all. And y, if it is 4, then x is 8. So it is also satisfied. So y is less than 8, x is greater than 4. Similarly, अगर y value 3 है, then x will be 6. So by using this, we are talking this x value. So it is also one possibility. Y is less than 8 and x is greater than 4. Similarly, if you take y is 2, if y is 2, then x will be coming as 4. X is coming as 4. अगर आपका y value 2 रहे तो x value is coming to be 4. But इसका कंडीशन के हिसाब से देखें तो x must be greater than 4. x 4 से ज्यादा होना पड़ेगा, x 4 से बड़ा होना चाहिए. But what you are looking, x is coming equal to 4. Based on this, we are looking here, this is not possible. This is coming as not possible solution. It is coming to be not possible solution. But if you look to other possibilities, we are looking to other possibilities, these are coming to be the possible solutions. These are coming to be the possible solutions. So how many possible solutions अपने पास है अभी? We count here number of possible solutions. अपना possible solutions है 1, 2, 3, 4, 5. तो number of possible solutions है 5. के हिसाब से for this numerical question अपना आंसर है 5. So answer to this numerical question is 5. So this question was asked in 2001. Of course, it was a question for 2 marks. 2001 paper में a question related with the synchronous counter. जो clock है, clock is coming to all these D flip-flops. Once clock is common to all the flip-flops, it is a synchronous counter, right? So this question is related with the synchronous counter. What is the given data in the question? If you look, consider the circuit given below with the initial state Q01, Q1, Q2, 0, 0. So initial state बताया Q01 है and other 2 flip-flops का output 0, 0 is a given data. It is the initial state, that is the name what is mentioned here. The state of the circuit is given by the value 4Q2, 2Q1 plus Q0. So based on this, इसका meaning क्या है? This flip-flop is the most significant bit flip-flop, and so on. The leftmost in this order is the least significant bit flip-flop. Least significant bit flip-flop. So basically, what we are looking, because of these 3 flip-flops, ये 3 flip-flops होने की वजह से a LSB will be always the power of 2 to the power of 0 for binary 2 power is 0, and Q1 के लिए 2 to the power of 1, Q2 के लिए 2 to the power of 2. So this is the same thing he is mentioning, 4Q2 plus 2Q1 plus Q0. So while looking to some additional information, confused nahi hona. There is no need to say this, but he is mentioned while looking to that, don't look at something else. There is nothing. Okay. क्वेश्चन में क्या बताया? Which of the following is the correct state sequence for the circuit? So options में ABCD options में पर इन ईच ऑप्शन स्टेट का इक्वल डेसिमल नंबर लेके बताया, स्टेट का इक्वल डेसिमल नंबर बताया। अगर ए स्टेट का इक्वल नंबर देखे तो आपको मिलेगा 1, बिकॉज इसको सब्स्टिट्यूट करो, Q2 Q1 0 0, फर्स्ट टू टर्म 0, Q0 इज 1, तो स्टेट डेसिमल नंबर इज 1। So what is the state sequence is asking? A state sequence अपन आंसर बताना बोले तो while applying the clock, you have to look what is the next state. What is the next state? While applying the clock, we need to check. So our work is going while applying the clock. तो क्लॉक अप्लाई करने के बाद नेक्स्ट स्टेट क्या है अपने को पता चलना बोले तो एक क्लॉक देने के पहले ये फ्लिप फ्लॉप का इनपुट्स क्या है अपने को मालूम होना चाहिए। ये सर्किट कनेक्शंस के हिसाब से देखे तो वी आर लुकिंग हियर फ्लिप फ्लॉप 2, आई कैन नेम MSB फ्लिप फ्लॉप 2, फ्लिप फ्लॉप 2 बोल के मैं बोल सकता हूं। तो इसके हिसाब से फ्लिप फ्लॉप 1 बोल सकते हैं इसको फ्लिप फ्लॉप 0। तो फ्लिप फ्लॉप 2 का इनपुट D2 क्या है, D2 is Q1, D2 is Q1। सिमिलरली फ्लिप फ्लॉप 1 देखो, फ्लिप फ्लॉप 1 इफ यू आर लुकिंग, फ्लिप फ्लॉप 1 इनपुट इज D1 है कनेक्शन के हिसाब से Q0। सिमिलरली फ्लिप फ्लॉप 0 का इनपुट देखिए तो फ्लिप फ्लॉप 0 इनपुट इज D0 कनेक्शंस के हिसाब से देखिए तो वी आर लुकिंग D0 is basically coming from the output of this exclusive OR। exclusive OR का इनपुट्स क्या है, एक इनपुट है Q2, दूसरा इनपुट है Q1। so that XOR output is this is Q2 exclusive OR Q1, Q2 exclusive OR Q1, Q2 exclusive OR with Q1। तो बेसिकली अपना इंटरेस्ट क्या है while applying the clock signal, उसका स्विचिंग सीक्वेंस क्या है we want to identify। वो स्विचिंग सीक्वेंस आइडेंटिफाई करना बोले तो we need to apply the clock। तो क्लॉक अप्लाई करने के बाद नेक्स्ट स्टेट क्या है पता चलना। तो नेक्स्ट स्टेट कैसा पता चलेगा, इफ यू नो क्लॉक डालने के पहले पर ईच फ्लिप फ्लॉप इनपुट्स क्या है अपने को मालूम होना चाहिए। So from the given connections, these are the equations for flip flop 2, flip flop 1 and flip flop 0 respectively। Now it is the initial state, it is the given data। इसके हिसाब से देखें तो D2 is Q1 is 0 means एक क्लॉक देने के पहले फ्लिप फ्लॉप 2 का इनपुट is 0 because Q1 is 0। D1 is Q0 क्या है 1 है, तो क्लॉक देने के पहले Q0 is 1 and D0 क्या है, it is the XOR between Q2 and Q1, 0 exclusive OR with 0 is 0, right। तो क्लॉक देने के पहले these are the inputs। now we are applying the clock। तो क्लॉक अप्लाई करने के बाद what is the next state we want to identify, इसके लिए we need to know the truth table of D flip flop। तो truth table of the D flip flop तो आप सब लोगों को मालूम है। तो whatever the D input we are having, it is coming as the output, all of you know well। तब तक क्लॉक 0 है, इनपुट कुछ भी होने दो, नेक्स्ट स्टेट सेम एज द प्रीवियस स्टेट। एज एंड व्हेन क्लॉक वी आर अप्लाइंग, अगर D 0 रहे तो नेक्स्ट स्टेट 0 मिलेगा। इफ D is 1, एज एंड व्हेन वी आर अप्लाइंग द क्लॉक नेक्स्ट स्टेट is 1। ये तो ट्रूथ टेबल ऑफ द D flip flop आप सब लोगों को मालूम है, के हिसाब से वी आर लुकिंग नाउ हियर। तो व्हेनेवर वी आर अप्लाइंग द क्लॉक, फ्लिप फ्लॉप 2 का इनपुट 0 है, क्लॉक डालने के बाद फ्लिप फ्लॉप 2 का नेक्स्ट स्टेट मिलेगा आपको 0। क्लॉक डालने के पहले फ्लिप फ्लॉप 1 का इनपुट इज 1, क्लॉक देने के बाद फ्लिप फ्लॉप 1 का आउटपुट 1 मिलेगा। क्लॉक देने के पहले फ्लिप फ्लॉप 0 का इनपुट 0 है, सो क्लॉक देने के बाद इट इज 0। सो व्हाट एवर द नेक्स्ट व्हाट एवर द इनपुट वी आर हैविंग दैट इज अ आउटपुट आफ्टर द क्लॉक। ये तो मालूम है आपको डी फ्लिप फ्लॉप का, उसके हिसाब से वी आर स्पीकिंग इट इज द नेक्स्ट स्टेज। तो इसका डेसिमल नंबर निकाले तो वी आर हैविंग द डेसिमल नंबर फॉर दिस, डेसिमल नंबर फॉर दिस इज 2, इसका डेसिमल नंबर था 1, इसका डेसिमल नंबर 2। So we are looking here, initially started with 1, later it is coming to 2। उसके हिसाब से ABCD ऑप्शंस में अपन देखे तो दिस इज नॉट पॉसिबल। 1 से शुरू हुआ बट क्लॉक देने के बाद 3 मिल रहा, वो पॉसिबल नहीं है, 2 मिलना चाहिए। एंड सिमिलरली डी ऑप्शन देखे तो स्टार्टेड विद 1, क्लॉक देने के बाद 6, ये भी ऑप्शन नहीं है। सो दैट among the B and C, 1 may be the possible answer। among the B and C, 1 may be the correct answer। एक ये दोनों में B और C में एक करेक्ट आंसर है। This is a multiple choice question only। So now this is the present state of this counter। This is the present state of this counter। Now we are looking before clock signal, what are the inputs of the flip flops। So Q1 is now 1, Q0 is 0, exclusive OR between Q2 and Q1, XOR between Q2 and Q1 is 1। So after first clock pulse, based on this present state, we are having, these are the inputs 1, 0, 1 are the inputs respectively, flip flop 2, flip flop 1 and flip flop 0। Now apply the clock। It is in sequence, second clock pulse हो गया 1, 0, 1। So what is the input we are having? It is the next state after clock, so that it is the state of the counter। It is the state of the counter। So उसका decimal number निकाले तो this decimal number we are looking as 5। This decimal number we are looking as 5। So that sequence देखिए तो 1, 2, 5, 1, 2, 5 इधर चल रहा काम, इधर देखिए तो 1, 2, 7 मिल रहा है, इधर 7 दिया बट मिल रहा 5, इधर दिया 7। उसके हिसाब से definitely this is not going to be the answer। It is not going to be the answer। So option A, option C, option D को हटाया। So based on this, definitely answer supposed to be option B होना चाहिए। Answer supposed to be option B। तो अगर आप ये क्वेश्चन लास्ट मिनट में अटेम्प्ट किया, no need to go for further clock pulses। Without going to further clock pulses, you can pick the answer as option B। You can pick the answer as a option B। Anyway, we'll work out now here। It is not anyway exam time। In the exam hall, you can do like this, but here as a learning process, let us look the full length work। So now based on this present state inputs देखिए तो Q1 is 0, Q0 is 1, XOR between Q2 and Q1, 1 exclusive OR the 0 is 1। When you apply the clock signal, it is 0, 1, 1। So based on this, the decimal value we are looking here, it is a 3, it is matching, you can see। Now based on this present state, the inputs if you look, Q1 is 1, Q0 is 1, XOR between Q2 and Q1 is 1। So these are the inputs based on this present state। When you apply the clock, it is coming to the fourth clock pulse। So what is the input we are having? It is coming to be the respective flip flop outputs। So based on this, the equivalent decimal number, state number, we can speak as a 7। So the 3 के बाद 7 मिला। So it is going in proper order। So Q1 is 1, Q0 is 1, XOR between Q2 and Q1 is 0। So these are the inputs to respective flip flops after this fourth clock pulse, or before fifth clock pulse. These are the inputs। Now as and when we are applying the clock, the next state is this, right? So equivalent decimal number इसके लिए देखें तो we are looking as a 6. So 7 के बाद में 6 मिल रहा, matching. So Q1 is 1, Q0 is 0, right? Q0 is 0. XR between Q2 Q1 is 0. When you apply the next clock pulse, of course, next clock pulse happened to be 6. 100 is giving 100 as the respective flip-flop outputs. So that decimal value, if you are looking here, it is coming to be 4. Right? It is coming to be 4. So if you are looking here, it is 1, 2, 5, 3, 7, 6, 4. It is matching. And it is enough as far as the question is concerned. It is enough as far as the question is concerned. So answer for this question, definitely it is answer is option B. A question का answer B. अगर आपको further interest है समझो, you are having further interest, you can see Q1 is here 0. Q1 is 0. Q0 is 0. XR between Q2 and Q1 is 1. So these are the respective flip-flop inputs after 6th clock pulse. When you apply the 7th clock pulse, the next stage is coming to be 0, 0, 1. It means the repetition started. So that we are extending further, it is to be like this: 1, 2, 5, 3, 7, 6, 4. बाद में repeat हो रहा, बाद में it is repeating. But in this question, that is not required. In this question, we can stop after 6th clock pulse. Anyway, finally, the conclusion on this question is, the answer to this question is option B.